Our planet Earth, a vibrant blue marble teeming with life, thrives under the constant gaze of a powerful star, the Sun. Its warmth sustains us, its light fuels our growth. But the Sun is a complex being, capable of both nurturing and unleashing immense power. An aurora borealis painted Portugal's sky pink on Friday night, May 10, 2024. This phenomenon is recurrent in the Arctic and Antarctic polar circles, but this time, it happened in several areas of the country. At the beginning of November, on the 5th, it was also possible to see northern lights in Portugal. Before that, it had only happened in Portugal in the 1930s. People from other European countries, including Britain, Denmark, and Germany, were also able to marvel at the unusual and spectacular sight of the northern lights on Friday night. This event was the consequence of a severe solar storm. Today, we'll delve into the fascinating relationship between the Sun and our climate. We'll explore the Sun's cycles of activity, how they influence the Earth's temperature, and the potential impacts on our future. Imagine a giant ball of hot plasma, constantly churning and swirling. This is the Sun's core, where nuclear fusion creates the energy that reaches Earth. But the Sun's not just a steady beacon. It goes through cycles, like a beating heart, with periods of high and low activity. These cycles, roughly 11 years long, are marked by the appearance of sunspots, cooler, darker regions on the Sun's surface. The more sunspots, the more active the Sun. And this activity can have a surprising influence on Earth. The Sun's energy bathes Earth, warming our planet. But the amount of energy can fluctuate with solar activity. During periods of high activity, the Sun releases more energy, potentially influencing Earth's atmospheric circulation and ocean currents, which ultimately affect global temperatures. Interact with Earth's atmosphere, particularly the ionosphere, a layer that helps reflect radio waves. During solar storms, these interactions can disrupt the ionosphere, causing signal degradation or even blackouts for communication systems that rely on radio waves. High-frequency radio communication, used for aviation and maritime navigation, as well as some amateur radio frequencies, are particularly susceptible to these disruptions. Imagine a pilot relying on radio communication during a crucial landing maneuver, only to have the signal fade due to a solar storm. That's why scientists and communication companies closely monitor the Sun and develop strategies to mitigate these effects. By adjusting frequencies or using alternative communication methods, disruptions can be minimized. Additionally, space weather forecasting allows for early warnings, giving communication providers time to prepare. Fortunately, not all communication methods are equally affected. Satellites and fiber optic cables, which transmit data through light or electrical pulses, are less susceptible to solar storms. As our communication infrastructure evolves, the reliance on radio waves will likely decrease, making us less vulnerable to the Sun's temper tantrums. So, the Sun's a wild card when it comes to telecommunications. But with proper monitoring, adaptation, and technological advancements, we can ensure our connected world stays connected, even when the Sun throws a starry fit. While it is important to be aware of potential risks associated with solar storms, the notion of an impending internet apocalypse is unsupported by credible sources and scientific evidence. False claims and misleading information circulating on social media platforms have only fueled unnecessary panic. By relying on accurate information from reputable sources like NASA and expert opinions, we can separate fact from fiction and alleviate concerns about a global internet shutdown caused by solar storms. This influence, however, is subtle compared to the dominant factor in climate change: human activity and greenhouse gas emissions. Here's the truth. The Sun isn't going to suddenly save us from warming or plunge us into an ice age. Some argue that the Sun's past periods of low activity, like the Maunder minimum, coincided with cooler temperatures on Earth. True, but the Little Ice Age was a complex event with multiple contributing factors, and it actually lasted longer than the Maunder minimum itself. Interestingly, recent decades have seen both rising global temperatures and increased solar activity. This suggests that human activity is the primary driver of climate change, not the Sun's natural cycles. Now the sun can also throw a punch. Solar flares and coronal mass ejections, CMEs, are powerful bursts of charged particles that can impact Earth's magnetic field. While these events haven't caused major disruptions in recent times, a truly massive CME could potentially damage power grids and satellites. That's why scientists are constantly monitoring the sun, developing early warning systems to mitigate potential damage from extreme solar events. So, the sun, friend or foe? It's both. It sustains us, but it can also disrupt. The key is understanding its influence and preparing for its potential impacts. As we continue to research the sun and its effects on our climate, we gain invaluable knowledge to better navigate our future on this dynamic blue marble. Remember, the sun's a force to be reckoned with, but by understanding its dance with our planet, we can ensure a brighter future for generations to come.
Breathtaking sight like a